Okay, so 7.2, all we're doing is taking exponential functions and we're moving them up, down, left, right, like we've done every other equation that we've done so far this topic. So here's our equation. You guys have this in your notes. Oh, there we go. Is it a big K? Looks like a big K. Okay, so this is our equation. This works the same way as it did all the other times. Okay, so A is our vertical stretch. Okay, so that just means if A is 2, your y values are going to be 2 times as big. If A is a half, your y values are going to be half as big. So I'll just put this as a reference to show what's happening. All it's saying is if you have xy points, then a times y, right? Okay, c is our base. So if c, remember, is a fraction, then our picture is decreasing. And if c is a whole number, then our picture is increasing. Okay, this b here, this is our horizontal stretch. Ooh. Okay, and so it works the same way, except your x values are going to be affected, and it happens to be the opposite. So if I have a half there, that means my x values are twice as big, and if I have a 2 there, that means my x values are half as big. So we can write that. Here's some, if I had xy point, it doesn't write very good up there, sorry. It would be like 1 over b with your x and then your y point. That's kind of horribly ugly, but just 1 divided by, that's all it means. So it's just going to be the opposite. So if b is 4, then my x's are all going to be a quarter of the size. If my b is a third, then I times all my x's by 3. Okay, so this one works the same. This is a horizontal translation. My board's sleeping this Monday. So if it's a negative, you're moving to the right, and if it's positive, you're moving to the left. So negative is right, positive is left. And this is our vertical translation. And if it's positive, it goes up. And if it's negative, it goes down. Oh, this should be down. Okay, so we can use these to do the next examples. Okay, and the easiest way to do these, I still think, is you create a table and then you move everything, doing your points, making a new table, and then drawing it instead of drawing the graph and moving it everywhere. Okay, and then the key is to do all your stretches first, or your reflections. So stretches and reflections first, and then your ups and downs and overs second. Okay. So for example 1, we have this equation. We're not writing anymore. I quit. Okay, let's try again. Y equals 3 to the power of x. Remember, the x has to be in the exponent for all exponential equations. Okay, and it says consider the following equation. They gave us this table, and it's -1 1/3, 0 and 1, 1 and 3, 2 and 9, and 3 and 27. And then it says for the next equations, which are on the back side of your sheet, it says sketch the graph and the transformations, and then you got to state the domain and the range, the equation, and the asymptotes. Okay, so the first equation that we're doing is this is our equation. So we have a 2 in front. It's still 3 to the power of x, but then we have a subtract 4 up there. Okay, so what we have happening is we have a vertical stretch of 2, and then we have a horizontal translation of 4 to the right. Okay, so what we're going to do is we're going to do the stretch first, and we'll change the points. Then we'll change the points for the translation, and then we'll draw the picture from that. Okay. Well, I don't even think we have to, well, it says sketch the graph, but okay, so here's our points. If we have a 2 in front for a vertical stretch, that means our y's are all going to be multiplied by 2. So I'm going to go 1/3 times 2 is 2/3. Okay, so we have -1. Nothing happened to our x points right now. You know what? I'm just going to leave my x side blank for now, and we'll do the translation on that side. Okay, so all I'm doing is timesing my y's by 2. So 2 times 1/3 is 2/3. 1 times 2 is 2. 3 times 2 is 6. 9 times 2 is 18. And 27 times 2 is 54. Okay, and then this is a horizontal translation, meaning we add 4 to all of our x points. Okay, so we're going to add 4 to all the x points. Okay, so 4, we had a -1, we're adding 4, so we'll have 3. We were at 0, so we'd have 4 for the next one. The next one's 5, 6, and 7. Okay, so now this is our new table. We've done all the translations, and all you'd have to do is sketch those points. Okay, I don't know if we need to do that or not. All you do is make your x, y axis, and you'd go 3 over 2/3 up. So if that's 1, it'd be somewhere here. 4 and 2, so you'd be here. So your picture's going to look something like that. Okay. So you'd sketch the points, and then it says state the domain, the range, the asymptote, any x and y intercept. Okay, so what's the domain for this one? What's it for every single one of these? Not the domain? Yeah, XER. Okay, so that's the answer for all of these, basically, unless we, no, that's the answer for all of them, okay? The range, we never went up or down, so y has to be greater than 0, okay, because we're still not touching the 0 x-axis. Our asymptote is still where then? Yeah. It's the asymptote. And then do we have any x-intercepts then if we're not touching the x-axis? No x-intercept. And then our y-intercept is probably crossing somewhere here, right? So we'd have to find out what that is. So all you do is let x equal to 0. So you'd have your equation, and you'd have 2 to the power 3, and x is 0, so our power, whoops, I forgot the 3 there, would be -4. So you'd go 3 to the -4 on your calculator, find out what that is, 3 to the power of -4, and then times 2. And you should get 2 over 81. So that would be your y-intercept. Okay, so the next equation we are doing okay, this is what we have. So we have lots going on. We have a reflection on the x because there's a negative out front. So that means all your y values turn to the opposite sign. Okay, so I'm just going to write that original table again because they gave us the original table, -1, 1/3, 0 and 1, 1 and 3, 2 and 9, 3 and 27. Okay, so now that negative in front means all our x val or our y values are going to change to the opposite sign. Okay, so they're all going to become negative. Okay. Now that half in front means that we're going to cut all our y points by half. Okay, so I'll make another table and I'm going to divide all my y points by 2. Okay, so -1/3 divided by 2 is -1/6. -1 divided by 2 is -1/2. Then we have -3/2. -9/2, and you can make these as decimal points if you want instead of fractions. And then 27 divided by 2, -27/2. Okay, I just left mine as fractions. Okay, so what should we do next? Should we do the -5 part or should we do the 1/5 part? 1/5, because that's a stretch. Okay, so if our x values are being affected by 1/5, that means we're multiplying them by 5, right? Because opposite things happen. So all of our x points are going to get multiplied by 5. So -1 times 5 is -5. 0 times 5 is 0. And then we have 5. Then we have 10. And then we have 15. Come on, 15. There we go. Okay, and then our last thing is subtracting by 5. That means all our y's are going down by 5. So if we would have had it as decimals, it's probably easier. Okay. I have the table written out, but if you wanted to switch yours to decimals, that's fine. So all we're doing is subtracting each of these by 5. Okay, so our new points are, nothing happened to our x's this time. But our y's are now, this is -31/6, -11/2, -13/2, -19/2, and -37/2. Okay? And again, if you want decimals, then do that, because it might be easier. Okay, so I'm not going to draw this one out. It works the same way. All you do is put these points on the graph. Our domain is what? XER. Okay, but think of this now. We went down 5, right? So what would be our range? Y has to be what? Is it greater than or is it less than? Because our picture reflected, right? Okay, so less than 5, or -5, sorry. Okay, because our picture, if we were just to do a rough thought in our head, right, usually it would look like this, but now we've reflected it, right? So it should look like that. Okay, so then our asymptote now, it usually is at 0, but we've moved down 5, so our asymptote is at -5. And then if we want to find our y-intercept, you let x equal 0, so you'd have 1/2, 3 in brackets, x is 0, so 0 times 1/5 is 0. And then you have -5. So anything to the power of 0 is 1. So 1 times a half is a half. Subtract 5. And you should get, when you go a half subtract 5, you get negative 11 over 2. So that would be our y-intercept.